Okay, in this video I want to talk about the number e. E is a number that comes up kind of naturally when you're studying compound interest, like interest in a bank or interest in a loan. It also comes up if you're looking at exponential growth or exponential decay and lots of other places. So this number, I'm not going to go into why exactly this number is important, but this is a number that does happen to randomly pop up when you're studying these other things. It's approximately 2.71828 blah 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 blah. So it's a single particular number that has some significance to us. Just like the number pi, we've been told our whole lives is important when you're studying different properties of circles. The number e is going to be important when you're studying certain properties of exponential growth and exponential nonsense. So just like we have this number pi that we've seen before, we don't really care about too many of the decimal places, just that, the calculator will help us out, and it sometimes helps to remember, okay, pi is 3.14, or it's 3-ish. E is 2.7, 2.71, 2.72-ish. So if you remember E is about 2.7, good enough. Okay, so let's start off by talking about the graph. So this is going to show up in the function f of x is equal to e to the x. And so we talked about in the last video that exponential graphs are going to be determined by whether this base is bigger than 1 or smaller than 1, and e is 2.7, so that's bigger than 1. So we expect the shape to be more or less like 2 to the x. And actually, if I drew this on the same chart, on the same piece of graph paper as 2 to the x and 3 to the x, we know that e is 2.7, so it's right in between 2 and 3. So like 3 to the x would be slightly bigger, and 2 to the x would be slightly smaller. Still both really close though. So this is an exaggeration. They're actually all very, very close together until you get to like plugging in x as 100 or something. Then yeah, they're going to be different. But when we're only plugging in numbers like 1 and 2, then yeah, they're all pretty close together. Okay, so that's the idea of an exponential. What I want to look at now is a word problem that happens to use the number e. Okay, so I'm going to look at this example. The number of U.S. cell phone accounts in millions is given by 110.6 e to the power 0.125x. So that whole thing, 0.125x, is the exponent. And that's going to be somewhat common that we have a number and an x in the exponent. And then this isn't just an exponential, it also has a number multiplied by it. Okay, so when we look at, the question says how many cell phone accounts were there in 2004? If x is 0 in 2000, 2004 would mean x is equal to 4. And so that means really we're just plugging in f of 4, or we're plugging in 4 everywhere there's an x in the original equation. So e to the 110.6 times e to the 0.125 times 4. Okay, I don't know this off the top of my head. I'm going to pull out a calculator. There. Okay. So you're going to have to look and see where the E button is on your particular calculator. Mine, it's right here. I don't know how well this is going to come across on the screen, but it's actually the LN button, and then E to the X is right above that. And so it's in blue, so I'm going to have to hit second and then E to the X when I'm ready to type that. So keep an eye out for where the E is in your calculator. It might have an explicit E button. It might look like e to the x or e to the box. Or some older calculators actually have a button that says exp parentheses. Any one of these is going to mean that's how you get an e to show up on your screen. So I'm going to try and type in this expression, which is 110.6 times. So I'm going to put the multiplication sign in myself, and then my exponential. So I hit second, and then e, and then 0.125 times 4. And one thing I should mention, if you don't happen to have a calculator like this on hand, I know we had 1 or 2 people in class that didn't have a calculator, we're borrowing from a friend or something like that. keep in mind that your laptop or your cell phone should have a calculator, and if all of our homeworks and tests are going to be take home, then there's no reason to not be able to punch things into some kind of calculator. So find a calculator somewhere. If you're having any trouble, let me know and we'll figure it out. Okay, anyway, so the number we end up getting is 182, and I'll write down a couple of decimal places, 348. I'm going to round that to 0.35. So the question says the number of cell phone accounts in millions is given by blah, blah, blah. So this is how many million accounts there were.